Right. Greetings to great hosts. Thank you for joining us. This is Edu Flash Visual Academy. I'm going to present a class on determining or deducing the equation of an exponential, a drawn exponential equation. Okay, so by the end of this lesson, one should be able to deduce the equation of an exponential graph which is drawn. Okay, right. Now, in the previous lesson, we we're busy with deducing of the equation of a drawn hyperbolic function. Now, I'm supposed to look at deducing the equation of a drawn exponential equation. Okay, right. So I'm going to say just as subtopic to this determining determining the equation determining the equation of a drawn right. Sorry about that. Um, let's try it again. This is determining 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 the equation of a drawn exponential exponential a drawn exponential function. Okay, so look at this. Right. Now, an exponential equation, remember, it is given by y equal to um, a b to the power of x minus p plus a q. Right. That is the equation, the general or the standard form of an exponential equation. So an exponential equation, if you look at it, there are four parameters. There is A, there is B, there is P, there is Q. Each and every parameter, remember, it comes with its own effect. Q shifts the graph up, down, P to the left or to the right, B is the base, it determines the shape. Then A stretches or it shrinks the graph, uh, and A also reflects the function along the x-axis if it's negative. Okay, those are the parameters. Now, since there are four parameters, for you to come up with an equation of an exponential graph, um, you need four different facts. Hence, with an exponential function, at times, or it is imperative to note that they are supposed to give you a suggested equation that you're going to use to come up with this equation. Otherwise, you'll have to create um, four different equations out of four different facts that you are given on the graph. Okay, that's an exponential equation for you. Okay, right. There is only one case that you should consider under this one for you to come up with the equation of an exponential graph. And this you use when given the horizontal asymptote. Right, the horizontal asymptote. Right, and at least one point, at least one point where the graph, where the graph passes through. Okay, right. Now, something of this sort. This is the case that, the only case that you're supposed to consider when you're deducing the equation of a drawn exponential graph. Now, the first example to this, my first example, call it example number 1. Determine the equation of the graph below. Determine the equation of the graph below. Right, so I am given a graph, and that graph is something of this sort. All right, got a function like this. You also label it y, and that is x. Right, I'll come and draw. This is y equal to 2. Right, this is a generally increasing exponential graph, which is 1 and 6. Okay, you are also further given that f of x, which is the function given, is 2 to the power of x minus a p plus a q, something like that. Okay, right. Determine the equation of this drawn graph. That's our question. Right. How do I come up with the equation of this drawn graph? First, this is an exponential function. And what am I given? I'm given the horizontal asymptote. And the horizontal asymptote is y equal to what? Q. If the horizontal asymptote is y equal to 2, I'll come and say this is y equal to 2 to the power of x minus a p plus a q. But your q in this case is equal to what? 2. Remember, the horizontal asymptote, we always know that this is y equal to what? Q. So if y is equal to 2, then it means therefore q is equal to 2. That's where I'm getting it from. Right, so I'm going to substitute now and say this is y equal to 2 to the power of x minus a p, x minus a p plus your q. So I'll come and say plus my q, which is 2. Okay, right. From there, I'm now going to trace the graph. Do I have another point where it passes through? Yes, I've got another point where the graph passes through. And at that point, x is 1 and y is 6. I'm looking for another point where this passes through simply because there are 3 unknowns there, y, x, and p. So if I look for a point where it passes through, I'll get the value of x and get the value of y there. Then the only unknown which is left is what? It is p. So 6 is equal to 2 to the power of what? 1 minus a p plus a 2, something like that. Transpose that. If I transpose this, this is going to be 6 minus 2 is equal to 2 to the power of 1 minus p. Okay, which is now 4 is equal to 2 to the power of 1 minus p. Right. If you look at this, allow me to divide that. This will be what? 4 is equal to 2 to the power of 1 minus p. I'm still solving. I'm still solving. This is an exponential equation, and you can see that p is an exponent. Since p is an exponent, I can make the basis the same because this is an exponential equation. Make the basis the same, then equate the exponent. So this is 2 equal to 1 minus a p. Right. Now transpose that. This will be 2 minus 1 equal to negative p. So 1 is equal to what? Negative p. Divide both sides by negative 1. So in this case, your p is going to be equal to negative 1. So the equation of this, I can come and say, therefore, what is going to be the equation? This is going to be f of x is equal to, that is equal to what? 2 to the power of what? X minus 1, right? Plus a 2. So in essence, this will be 2 to the power of x plus a 1 plus a 2. That is the equation of that function. Okay, right, that's what you're supposed to come up with. That was the equation of your exponential function. Right, I'm going to divide this into 2. I'm going to divide this one into 2. Look at that. Okay, good. Right, now I've divided my board there. I'll come to my example number 2. That's my exponential graph. Remember, I said an exponential graph is very, very important. Your examiners, they are so much in love with this one. So I'm going to give you quite a number of examples there so that you can um, get more and more exposure on this one. Right, now let's look at this. Determine, that's the example, the equation. Determine the equation of the graph f, okay, equal to a times b to the power of what? X plus a q, right? And I'm going to draw this. My graph is something like this. Okay, there you go. That was a generally decreasing function, which comes like that. This was given to be 3. This is -1 and 6, something like that. Okay, that is your function f, which is a generally decreasing exponential function. I'm supposed to come up with the equation of this. Right, for me to come up with the equation, I know that this is going to be y equal to a b to the power of x plus a q. Okay, right, that's your f of x. Right, the first thing I can see that the asymptote, I've got a horizontal asymptote, and in this case, the horizontal asymptote is y equal to 0. So in effect, your q is going to be 0 in this case. So this is going to be y equal to a times b to the power of x plus a q, which is 0. Okay, now from there, I'll look for another point where it passes through. When x is 0, y is equal to what? 3. Right, I've got 2 points, 0, 3, and -1 and 1. Advisably, start with the point on the y-axis where x is 0. So it means this is 3 equal to a times b to the power of 0. Once b is a power of 0, then it means I'm now remaining with one unknown, which is that times 1. So therefore, your a is equal to what? 3. I'll take 3, plug it back there. It becomes y equal to 3 times b to the power of x. I'm left with what? B now. Look for another point where it passes through at x equal to -1. B, y is going to be equal to what? 6. So I'll substitute now. 6 for y and 3 times the b is -1. X is -1. So it means 6 is equal to 3 times 1 over b, something like that. Okay, right. I can cross multiply. You can all see that if I cross multiply this, will give me 6b is equal to 3, something like that. Divide by a 6, divide by a 6, your b is equal to 1 over 2. So this equation, if I am to calculate, if I'm to deduce it, I'll say, therefore, f of x is going to be equal to a, your a is a 3, b, what is your b? It's a half in brackets, o to the power of x. Your q is 0. So my equation will be something of this sort. Okay, right. That's how you determine the equation of such an expression. Okay, right. Given something like this, I'm now going to, let's go to the next example. Same thing. This is basically an exponential equation. Okay, right. Now I'm going to say my example number 3, your example 3. If you look at this question, says determine, okay, sorry about that, determine the equation of determine the equation of, okay, this is f of x equal to b to the power of x plus a p plus a q. Right, now I've got something like this, something of this sort, right? And you were given something like that, which is going to be what? Y equal to -3. Okay, then it goes out like that. It passes through point -1 and also point 1 and 1, something like that. Okay, right. The question says determine the equation of the graph f. This is an exponential function. How many parameters do I have? How many unknowns do I have? There is b, there is p, and there is q. So there are three unknowns. Since there are three unknowns, I'm supposed to identify three facts on the graph. The first one, it is basically the asymptote, which is y equal to q. If y is equal to q, it means my q, therefore q is equal to -3. I've deduced the first aspect. The second aspect, I've got a point like that where it passes through. I also have a point like that one where it passes through. So I'm now going to come and say y is equal to b to the power of x plus a p plus a q, something like that. Now, if that is the case, I'm now coming to say but q is equal to -3. Whatever I've deduced, I'll substitute it back into the expression, right? This is -3. From there, remember I said advisedly, I've got two coordinates. The first one is what? 0 and -1, and also 1 and 1. I'll start with the y-intercept. Then I'll come to 1 and 1. Why the y-intercept? Once x is 0, it becomes a little bit simple to simplify. So I'll come and say when y is -1, this is b, what? 0 plus p minus a 3. Transpose -3, that will be b to the power of p. So 2 is equal to b to the power of p. That's equation number 1. Okay, so that's equation number 1. I'll now substitute the next point. We know that y is equal to b to the power of x plus a p minus a 3. So I'm going to say x is equal to 1 when y is equal to 1. Substitute now. This is 1 equal to b to the power of 1 plus p minus a 3. Okay, right. There you go. Transpose the 3. It goes over. It becomes 1 plus 3 equal to b to the power of 1 plus a p, which is now 4 equal to b um, to the power of 1 plus a p, right? That is equation number, this is equation number 2, right? Now to proceed with this, to continue with this, I'm just going to go to the other side. So it means I've got two equations now, b to the power of p equal to 2. Allow me to call this equation number 1. So this is b to the power of p, something like that. Okay, right. Then I know that 4 is going to be equal to b to the power of 1 plus p. That's equation number 2. I can break down equation 2, which is b to the power of 1 times b to the power of p. That's equation 2, still simplified. So I'm going to come and say but, okay, let me say but b to the power of p is 2. So it means if I've got b to the power of 2 there, I'm going to substitute it with the value of b. b to the power of p is 2, so it means this is b times 2. All over 2, all over 2, which is 2 is equal to b. So my b is equal to what? 2. Okay. If b is 2, what is going to be your p? From equation 1, I know that b to the power of p is equal to 2. But b calculated is what? 2. So this is 2 to the power of p equal to 2 to the power of 1. Therefore, my p is going to be equal to what? 1. Now, I've got all the parameters needed on my function. It means what? Y is now equal to what? B. We said b is 2, x to the power of what? 1 plus your q. Your q is minus 3, so that will be negative 3. So this function, which is f of x, is equal to 2 to the power of what? X plus 1 minus a 3, something like this. This is my example number 3. The whole point was to determine the equation of a drawn exponential function. Okay. On this, the last example is uh, going to be incorporating a lot of analytical questions there, but equally on an exponential equation. It's just trying to consolidate the information that we got in other lessons. So I'll just take this as my example number 4. Right, that's our example number 4. Allow me to write that again. This is example number 4, something like that. Okay, which is basically on analysis. Pretty repetition of some of the things that we did in the previous classes, but yet very important for us to refresh again. below, sketched below is the graph. Sketched below is the graph of f of x, which is what? Equal to that, where k is greater than what? 0 as a restriction. So I've got a graph like this, a basic graph which goes out like that, generally increasing. That's labeled 1 because the basic function, which is 4 and 16, something like that. The first question says determine the value of k, b, determine the equation of f inverse. Then C, someone says draw on the same set of axes the functions f of x and f inverse of x. Okay, then from there I'm now coming to my D. Right, on your D says determine the value of x for which f inverse is less than 0. Then E, determine the value of x for which f inverse is what? less than or equal to -1. Okay, right. The last one there says determine the values of x for which f of x times f inverse is greater than what? 0. Okay, right. Allow me to split this so that I can start with my solutions there. Right, let's quickly look at this example. The first aspect is to determine the value of what? K. I know that y is equal to k to the power of x, and I'm looking for what? K. Right. For me to get k, this is your a, which is y is equal to k to the power of x. For me to get k, I'm going to trace and look for a point where this passes through. In that particular point, I know that x is a 4, while y is what? 16. So this is going to be 16 equal to k to the power of 4. I'm trying to get the value of k, so I'll get the fourth root of both sides. Fourth root of both sides, that will be plus or minus a 2, which is equal to k. So k is equal to 2, since k should be greater than what? A 0. So this is the value of k that they are looking for. Okay, right. From there, determine the inverse. Going to come and say my B, it says determine the inverse. Right. For your inverse, we know that we are looking for the inverse of what? 2 to the power of x. The first thing is to change. Remember, this is exponential and its inverse is what? Logarithmic. So it means I'm going to interchange variables. That is the first thing. X becomes y becomes x. Then the next thing is make y subject. How do I make y subject? Convert this from logarithmic form. It means this is y. From exponential form to logarithmic form. Y equal to what? X base of 2. Okay, so the inverse. F inverse is going to be equal to what? Log x base 2. You can see that the inverse of an exponential function is logarithmic. Okay, let's look at C. My C says draw. So I'm supposed to draw two graphs there. One for f of x, the other one f inverse. For f of x, this is a basic exponential function which is generally increasing. So it passes through 0 and 1, and it's generally increasing. So it starts from the asymptote like that. That will be my f. The next one is to get f inverse. F inverse. Remember, the inverse of an exponential function which is increasing is the logarithm which is also increasing. So this log function, it also passes 1 and 0, and it's generally increasing. So it will go out like this. And remember, there is a line of reflection. Our line, don't leave the line of reflection. Our line of reflection, which you should label as y equal to what? X. So this is your f inverse. Okay, I've managed to draw my two graphs on the same set of x's. I'm now looking at D. Now D says determine the values of x for which f inverse is less than 0. F inverse is less than 0. We are looking for, they are saying f inverse where f inverse is less than 0. In other words, I'm looking for where f inverse is below the x-axis. That's how you deduce that. So if you trace your f inverse from negative infinity, you see that f inverse is not there until you reach x equal to 1 line, right? From x equal to 0 line going onwards, that's where you can start seeing it. And you can see that from 0 less than x less than 1, the graph is below the x-axis, meaning to say you can see that this graph is below the x-axis at this interval, which is from x equal to 0 to that particular point where x is equal to what? 1. So this is the point, this is the interval where f inverse is below the x-axis. Okay, right. Now let's look at E. My E says determine the values of x for which f inverse is less than minus 1. F inverse is less than what? Minus 1. For me to solve such a problem, I'm going to insert the graph of what? Y equal to negative 1, because there are now two functions. I've got f inverse less than negative 1. My f inverse is the logarithmic graph, which is log what? X base 2. And we are saying it's less than another graph, which is negative 1. So it's as good as if I'm to quickly do that, I know that this is generally increasing. And I'm going to draw the graph y equal to negative 1. If I'm to draw the graph y equal to negative 1, I'm now comparing the log graph, which is your f inverse, and y equal to negative 2. In other words, I'm saying where is the log graph? Below y equal to what? Negative 1. And you can see that below it is from x equal to 0 to the point of intersection. So I'm supposed to get that point of intersection. And how do I get that point of intersection? I can simply say log x base 2 is equal to negative 1. Right? So this is x equal to that. So therefore, the point of intersection is equal to what? X is equal to a half. Right. So which interval do we have the log graph below the line y equal to what? X. It is from 0 to the point of intersection. So it means this is going to be 0 less than x less or equal to a half. This is the interval that you are looking for. Then lastly, determine the value of x for which f, we are looking at what? F of x times f inverse is greater than what? 0. I've got two functions that are multiplying f and its inverse. When they multiply, they get something which is greater than 0. Anything greater than 0 is a positive. So for you to multiply two quantities and get a positive, it's either this is a positive, while that is a positive, or this is a negative, while that one is what? A negative. So I'm looking for where the graphs are both above. Remember, positive on f of x, it means above the x-axis. Positive on f inverse, it means above the x-axis. Negative means below. So I'm looking for where the two graphs are either both above or both below. Right? If you go back to your functions there, you realize that from negative infinity right up to x equal to 0, it's only the exponential function which exists. Then from 0 onwards, one is above, the other one is below, up to x equal to 1. So if you look at this graph, something like that, from x equal to 1 onwards, both graphs are above the x-axis. So that interval becomes what? X greater than 1. From x greater than 1 onwards, the graph is above the x-axis. Okay, that's how you will analytically solve such a problem. Thank you so much for your time. That was that, and I'm going to look at this and say this is a very, very common question in your exams, and one needs to fully comprehend that concept. And I'm going to bring this again in further questions that we are going to be looking at. But for starters, it is imperative for you to understand those basics. Thank you. Enjoy the rest of your day.